Previously, we discussed the reaction mechanisms of ketoprofen, in which the last step involved hydrolysis. Today, we will explain it to you. The mechanism begins with the protonation of the nitrogen atom of the nitrile group under acid conditions. A water molecule attacks the carbon of the protonate nitrile, and the carbon-nitrogen triple bond changes into a double bond. The water group attached to the carbon loses a proton and hydroxyl group is formed, producing the immediate intermediate. The nitrogen of the intermediate becomes protonate again. An electronic rearrangement occurs in which the oxygen forms a double bond with the carbon and the carbon-nitrogen double bond breaks, producing a protonate amide. A water molecule removes a proton and the neutral amide is obtained. The oxygen atom of the amide carbonyl group becomes protonate. Another water molecule attacks the carbonyl carbon and the tetrahedral intermediate is formed. One of the hydroxyl group loses a proton and the amino group becomes protonate. The tetrahedral intermediate collapses. The carbon-oxygen double bond is restored and the amino group leaves the molecule as ammonia, producing the protonate carboxylic acid. A water molecule removes the excess proton and the neutral carboxylic acid is obtained. The oxygen atom of the ester group takes a proton from the acidic medium and the protonate ester is formed. Finally, a water molecule attacks the carbon of the protonate ester, initiating the ester hydrolysis for the next stage of the mechanism.
A water molecule attacks a hydrogen, causing the electrons to return with the oxygen, making it neutral. The electrons of the hydroxyl group go down to reform the double bond carbon-oxygen, repelling the attacking ion. These attack the hydrogen of the protonate oxygen, leaving the corresponding carboxyl acid. The carboxyl group eats this protonate. Oxygen loses its proton, generating a negatively charged carbonylate ion. We have reached the base of the carboxylation. The electron pair of carboxylate oxygen moves to form a double bond, which breaks the adjacent carbon-carbon bond. This releases a carbon dioxide molecule and generates an intermediate carbanion stabilized by the aromatic system. Finally, this carbanion a proton of the middle. As a result, we obtain the product where the original carboxyl group has been replaced by a hydrogen after the loss of carbon dioxide.
I hope you have no doubts. If so, leave a comment. Thank you for watching and see you in our next video.